Hello everyone, here's a quick video on rational inequalities. The video stopped on me while I was recording it, so I'll go over again. So here we have x plus 1 divided by x plus 3 greater than or equal to 2. So when you're doing a rational inequality, you want to make sure that everything is on one side. So we will move the 2 to the left, so that becomes, when you move something from one side of the equation to the other side, you change the sign. So 2 was positive, when we move it, it becomes negative 2. So that negative 2 is the same as over 1, so now we need a common denominator, x plus 3 and 1. So the common denominator of x plus 3 and 1 will just be x plus 3. So we will multiply x plus 3 here on top and bottom. So we copy the first part, and the second part we multiply x plus 3 on top and bottom, greater than or equal to 0. When you move the 2 to the left, what's left on the right side is just 0. Alright, so since they have the same common denominator, we can combine them now. So we have x plus 1, and then this would be a negative 2 times x, that would be negative 2x, and then negative 2 times positive 3, that would be negative 6. Since the denominators are the same, we can keep one of them, so that would just be x plus 3 greater than or equal to 0. Okay. So let's combine x and negative 2x would give you negative x, and then positive 1 minus 6 would be negative 5 all over x plus 3 greater than or equal to 0. Alright, now we have to solve each side of the equation, the numerator and the denominator for x. So you have negative x minus 5 equal to 0, and then you have x plus 3 equal to 0. So this would give you negative x equals positive 5, which means x equals negative 5. And this will give you x equals negative 3. Remember, when you move something from one side of the equation to the other side, you change the sign. And in this case, you divide by negative 1 on both sides. Okay, so here are the two numbers that we found. Now, we don't know which one is exactly the solution, so we'll do a test. Okay, and then we test all the boundaries. So here we are going to test from the smallest to the next one, right? So we'll test from negative. This is from negative infinity, we are going all the way to infinity. So we will test from negative infinity all the way to negative 5, and then we will test between negative 5 to negative 3, and then from negative 3 all the way to infinity. Okay, so the ordered pairs that we are testing here is between negative infinity and negative 5. Since it's greater than or equal to, we'll use a bracket there. But then again, we have to be careful with the 3, we cannot use a bracket there. So this would be also from negative 5 to negative 3, but we have to use a parenthesis here since the 3 is in the denominator, and then from negative 3 all the way to infinity. So this is what we are testing. Okay, so what value can we test between negative infinity and negative 5? We can test negative 6. Remember, negative 6 is on the left of negative 5. And then between negative 5 and negative 3, we can test negative 4. And then between negative 3 to infinity, we can test 0. Okay. Now we go to the original function, which is x plus 1. You can either go to the original function, or you can go to the negative x minus 5 and then x plus 3 to test it. Alright, so if we test negative 6, that would be a negative and then negative 6. Let me take it to a place you can see. So here you have, this is the function we will be using, negative 5, x negative 5 over x plus 3 greater than or equal to 0. Or you can go to the original function, it doesn't matter. Now we test these values, the negative 6, the negative 4, and the 0. So if we test the negative 6, we will say negative times negative 6 minus 5 all over negative 6 in parentheses plus 3 greater than or equal to 0. We have to put a question mark because we don't know if that's correct or not. So this would give you a positive 6 minus 5 all over a negative 6 plus 3 greater than or equal to 0 with a question mark, of course. So this would be 1 over, this would be negative 3 greater than or equal to 0. Now 1 divided by negative 3 is a negative number. Is a negative number less greater than a positive number? No. So this is false. So that means the first part is not the answer. So we can test the second one, which is a negative 4. So we go negative and then negative 4 minus 5 all over negative 4 plus 3 greater than or equal to 0. So that would give you 4 minus 5 all over negative 4 plus 3 is negative 1 greater than or equal to 0. So the top one gives you negative 1 divided by negative 1 greater than or equal to 0. So which is what? 1 greater than or equal to 0. So is positive number greater than 0? Yes. So this is a true statement. So we know that this is a solution. About the second part, the negative 3 to infinity. So we take 0 and substitute it in there. So the function is a negative times 0, and then minus 5 all over 0 plus 3 greater than or equal to 0. So this would just be negative 5 over 3 greater than or equal to 0. So negative 5 is a big number, bigger than the 3, so that means we'll end up with a negative number. So is a negative number greater than a positive number? No, so this is false. So the solution is just this part, which is what? Negative 5 comma negative 3 is the solution. And that's it. Thank you.